Arrays under the hood. So this is basic code initializing an array of 5 elements and incrementing them by 10. And this gives us a basic array. So let's take the first line, which is making an array of 5 elements. Well, an int is 4 bytes and we have 5 items, so we know we need to allocate 20 bytes for all 5 integers. So here's a table with 5 memory values, each initialized to 0, that takes up 20 bytes. So here we have another index position, and let's say we wanted to take array position at position I and set it to num. And in this scenario, let's say I is 2 and num is 20. So remember that int is the size of 4, so what we can do is we can start at the beginning of the array, which is, let's just call it 0. We can jump ahead 8 bytes because we know that we need the position 2 and int is the size of 4, so we jump ahead by 8. And then the next 4 bytes are the int that we need, so we can set those 4 bytes to 20, which sets it like that. So in the end, we have a formula sort of where we take the starting position and we add the index times how big the type is, in this case 4. So this is why arrays, at least in statically typed languages, need to have the same type for each index or for each item, and they need to start at 0 to make this mathematical equation work. So a little quirk of this, at least in C, in other languages they have guards protecting this, is let's say that I was 5, although there were only 4 indices. So it started at the beginning, 5 times 4 is 20, so we jump ahead 20 bytes, but we're out of the array, so it's sort of just other data. It could be another int, it could be a string, it could be a different array, it could be part of a whole different program. So what you're doing is you're accessing unavailable data, or unavailable to the array at least. And this comes because arrays are just in-memory subsequent values. They're not grouped together or anything, they're just subsequent values, which is also why another thing in C is if you declare 5 variables in a row, normally the compiler would declare each variable, so it'd declare A and then it'd declare B right after A because it'd be simpler. So this is a stack in memory. It's not necessarily an array, but just stacks of memory. And so you have the variables each defined, and then each defined after the next, which is usually what a compiler does, but sometimes it won't because there's memory there and it has to allocate somewhere else. But you have each value, so if you did A at position 2, it would give you 10 because that's the value of C, because it would jump ahead 8 bytes and get C. So another weird quirk. In other languages like Java, this would not work because of more safeguards put into the language. So another thing is, what about 2D arrays? So if the formula depends on the type size being the same, what about arrays or strings that do not have fixed sizes? Well, strings are basically arrays of characters, but the way that this works is instead of taking the value, you have a pointer to the value. So pointers are fixed values that have 4 bytes of memory. So here at position 0, we store 2 strings, ints and then w. So the first position, we store the pointer to the first value of the ints string, and then for the second value, we store a pointer to the first value of the second string, which is w. So this is what it does when it has something that's not a fixed size like arrays or strings. It'll just store a pointer to that value. So whenever you get the value, it'll see that's a pointer, go to where the pointer is, and get the value at that position. And these 3 items of the array and then the 2 strings could be anywhere in memory. That's the good part about having it a pointer, because it can just be anywhere in memory and it can get that stuff. So here we have an online C compiler that will basically shows an example of arrays. So here we initialize an array with malloc, and we set it to the size of 3. And what we can do here is we can get the value of the array, which is 12 bytes, and set the first position at least, or set the position to 10, which will take up 4 of those 12. So then what we can do is we can do plus 1 to the array, which it's plus 1 and not size of int because it already knows to go by size of int. So this will actually jump ahead 4 bytes, but we can call it 1 because C will do some stuff under the hood with that. We can set that to 0, and then we can jump ahead 2 spaces or 8 bytes and set that to 100. We can print all 3 of them, and then we free the array, and this will print out 10, 0, and 100. So those are how arrays work in not only C, but most languages, because most languages are built off of C. So once you get down to a lower level, this is how basically most of them work. And yeah, that's how arrays work under the hood.